We're going to solve for the moment required at point D to keep this system in equilibrium whenever an input force of 25 pounds is inputted on the A position. So we're given that theta is equal to 30, and to solve for this moment, we're going to take the summation of moments at the point D and set it equal to 0 for equilibrium. And to do that, we need to find the other unknowns in our system in this free body diagram. So to start with, we're going to find unknowns of the lengths of the rods. So to find length, first we'll start with length BF. So for length BF, that's going to be equal to 6 times the sine of 30, which will be equal to 3 inches. For length BE, we can say 10 times the cosine of 30, and that's equal to 8.66 inches. For length CF, this is just Pythagorean's theorem. So we take the square root of 6 squared minus 3 squared, and this will give us a length of 5.196 inches. Now we can say that the forces along the y direction is equal to 0. And just by looking at this free body diagram, so the y force that's inputted is this 25 pounds. So the only output force that can be outputted is at this point C, which has to also be equal to 25 pounds. So using that information, you can say that the y component at the point C of the force is also equal to 25 pounds. And we're now going to find the x component of the force. So to find the x component of the force, we can say that the summation of moments at the point B is equal to 0. So we're going to say that the sum of moments about the point B is equal to 0. And from the free body diagram, we can write out the following expression. So 25 times the length BE minus the y component of force at C times the length CF plus the x component of the force times BF. And we can plug in and solve for the x component since we know all the other terms. So after plugging in and solving for the term c of x, we get that c of x is equal to 115.5 pounds. Should be negative. So negative 115.51 pounds. And next we're going to solve for this CG length. And for that we can use Pythagorean theorem. So the length CG, that's going to be equal to the square root of h squared minus 5.196 squared. And that will give us a length of 6.08 inches. And finally, we can take the moment about the D position. So the sum of moments about d is equal to 0. And using what we have, we can say that that's going to be equal to negative c of x times cg minus c of y times dg plus the moment that we're trying to solve for. And we set that equals 0. And so we know the x component, we know cg, we know the y component, and we also know dg. So we plug in and we solve for the moment m. So the x component of the force at c times the length cg minus the y component of the force at the point c times the length dg plus the moment m is equal to 0. And solving for m, we get a value of 832.24 pounds inches.